Hello and welcome to Target 3, Mass versus Weight. What changes based on location, mass or weight? What are some differences you notice between mass and weight? Summarize these in your notes. Susie's mass here on Earth is 63.5 kilograms. Susie's weight on Earth is 623 newtons. 140 pounds. Susie's mass on Jupiter is still 63.5 kilograms. Susie's weight on Jupiter is 1,582 newtons, or 284 pounds. Notice that Susie's mass stays the same. It's Susie's weight that changes. Mass, m. Mass is the amount of matter in an object. Mass is the measure of the inertia of an object. Kick an empty can. It's easy to move. It has low inertia. But if we kick a can filled with sand, it's harder to move. Medium inertia. Kick a can filled with lead, bruise our foot, and we will barely move the can. High inertia. Mass is not volume. Mass is not weight. Mass is measured in kilograms, kg. Weight, F sub g. Weight is the force of gravity on an object. Weight is determined by the acceleration due to gravity, A sub g, or little g, at any location. Weight is a force, so it is measured in newtons, N. Mass versus weight. Weight depends on an object's location, while mass is only dependent on the number of and kind of atoms that compose the object. The same object on two different planets would have the same mass, but different weights. The pull of gravity, or weight, would be higher on a more massive object than Earth, like Saturn or Jupiter, and lower on a smaller object, like Mercury or the Moon. Weight and mass are proportional to each other at the same location. Doubling the mass of an object on the Moon or at any other location would cause its weight to double as well. Converting between mass and weight. To convert between mass and weight, use this formula. The force of gravity, F sub g on an object, is equal to the object's mass times little g. Fg equals mg. The acceleration due to gravity is equal to 9.8 meters per second squared. That's that little g, or that A sub g, near the surface of Earth. This value is constant, but valid only near the surface of Earth. Other locations have a different constant value. For example, the Moon has about 1/6 the force of gravity that the Earth has. Calculations. Mass to weight. If a woman has a mass of 50 kilograms, calculate her weight in newtons. We know that the force of gravity is equal to mass times the acceleration due to gravity, or F sub g equals m times little g. Filling in for the mass, we write 50 kilograms in place of m, and since we're on Earth, that little g is equal to 9.8 meters per second squared. Multiplying these two numbers together, we find that the weight of the object is 490 newtons. F sub g, or the force of gravity, is equal to 490 newtons. Calculations. Weight to mass. Calculate the mass of a 19,600 Newton elephant. We know that weight is equal to mass times the acceleration due to gravity. So we plug in for the weight. For Fg, we plug in 19,600 newtons, and we keep the variable m for mass. And for little g, we plug in 9.8 meters per second squared. Dividing both sides by 9.8, we solve for m, mass. And we see that the mass of this elephant is 2,000 kilograms.